In today's video, we're going to be taking a look at content streaming. Now, in order to understand content streaming, it's also important to understand replication. So if you haven't already, check out my video on replication, and this should help you understand how content streaming works. Now, in order to demonstrate content streaming, what I've done is created a baseplate project, and I've created a folder. And inside of this folder, I've created a load of parts, and these parts are just simply anchored parts with a spacing of 64 studs between them. And what I'm going to do now is go to the Test tab and start a local server with one player. And now we should see two windows. The server is on the left side and the client is on the right side. And because we have content streaming turned off, the server will replicate everything in the workspace to the client when they enter the game. And if the server makes a change, for instance, if I select this part at the top left, and if I move this part, we can see it replicates to the client. And if I turn on view and stats and network, we should see that when I move the parts, that the overall incoming kilobytes a second increases. So we can see it's currently at 0.15. And if I start moving this part, we can see it increases to 1.5. So let's now turn on content streaming and let's test again. So I'm going to first select workspace, and I'm going to come down to streaming enabled and turn this on. And I'm going to reduce the streaming target radius to 128. And then I'm going to go back into the Test tab and press Start to start a local server with one player again. So now we should notice that the server is still able to see all the parts within the folder, but the client is not able to see all the parts in the folder. So if we look in the folder, there are a lot less parts inside of this folder than there are for the server. And as the client walks around, we should see new parts get added to the folder as the server streams new content to the client. Another thing we should notice is if we go back to view and stats and network, and if the server selects this part at the top left, which has not been streamed by the client yet, and if we start moving this part, and if we look at the overall incoming kilobytes a second, which is currently at 0.15, if I start moving the part, you can see that it stays at 0.15 because the server knows that this part has not been replicated to the client yet. So the server does not stream the updated position to the client. So it consumes 0 network data. And if the client starts to walk towards that part, so if we keep walking up here, we should see the part pop in. And now that this part has been streamed to the client, the server now knows this, and so that when we move the part, we can see that the overall incoming kilobytes a second now does get affected by the movement of the part. So let me try to explain the difference between minimum radius and target radius. So if we imagine that this green dot in the center is the player's character, and this red circle is the minimum radius, and the blue circle is the target radius. So anything that's within the minimum radius will be sent from the server to the client at the highest priority. So the server will do everything within its power to make sure to stream the content inside of the minimum radius instantly to the client. Where anything that's between the red and blue circle, so anything over these areas over here, will be streamed to the client but not at high priority, and the server will be much more relaxed in how it sends these instances to the client. And anything outside of the target radius will not be sent to the client. So let's now take a look at streaming integrity mode. So we have disabled, minimum radius, and we have pools outside of loaded area. So at this current time, if you select default, it's the same as selecting disabled. So if streaming integrity mode is set to disabled, that means the client will never pause simulations when the instances have not been streamed to the client yet. But if we set integrity mode to minimum radius, then what this means is if any instances that are within the red circle have not been streamed to the client yet, that client will pause simulations until all the parts within the red circle have been streamed. So in order to demonstrate minimum radius, what I'm going to do is I've duplicated the folder many times so we have a load of parts at the top over here, and then I'm going to change the minimum and target radius to 256, and then I'm going to play the game. And now we should see that all these folders are empty that I duplicated, and if I teleport my character to the position where all these parts are, my client should pause the simulations until all the parts have been streamed in within the minimum radius. So if I set my character's position to -600, and we should notice that as soon as I press enter, the game should pause for a very short amount of time. And one thing we should take note is if we published the game and tested this inside of a real server, the amount of time for these instances to replicate to the client may vary, because currently we're testing within Studio, and when we test inside of Studio, we're running on a local server with artificial amount of delay. Now we need to be a little careful when using the minimum radius as the integrity mode, because it's possible to make it so it constantly pauses when playing the game. For instance, if I set this to 128 and also set this to 128 and press play, and if I start to walk forward, we should see that the game constantly pauses as new instances get streamed in. And this is because if the target and minimum are the same, there's no time for the instances to get streamed in within the blue area before it reaches the red area. So in order to fix this, we need to make sure that the minimum is less than the target. So if I reduce this back down to 64 and play the game, now we should see that there's enough time within the target radius for the instances to get streamed before it reaches the minimum radius. Now, using minimum radius as the integrity mode is prone to pauses, especially if your minimum radius is a high value. So what Roblox did, they added a new mode called pause outside loaded area. Now, in order to understand pause outside loaded area mode, we need to have an understanding of the replication focus property. So each player has a property called replication focus, and this property is going to tell the server at the position of where the client is replicating. So by default, this value is set to 0. And when this value is set to 0, it's going to use the player's character's primary part. So if we go back here, we can see that the player primary part is set to humanoid root part. So the server is going to replicate around this humanoid root part. And if we use the pause outside loaded area mode, this is also going to use the humanoid root part. And what it's going to do is say, if an instance has not been streamed within the bounding box of the humanoid root part, then it's going to pause simulation for the humanoid root part. So what this means is if I go to the server side and if I create a part and if I set this as the replication focus, so if I open the command bar and say game.players and get soupy, and if I say .replication focus equals workspace .part. So this is going to set this part as the replication focus instead of using the humanoid root part. So I'm going to press enter, and now if I move this part, it's going to make everything around this part replicate to the client. So we can see the part's currently over here. Now I should have network ownership of this part, so I can also move it on the client side and it should replicate to the server. So if I start moving this over here, we can see that the parts start to stream in. And at the same time, because we're using pools outside loaded area, if an instance is not streamed in around the bounding box of this part, then the simulation for this part will stop. So in summary, if we use minimum radius, if any instances within the minimum radius have not been streamed to the client, then the client will pause simulations. But if we use pools outside loaded area, it will use the replication focuses bounding box, and if any instances within the bounding box have not been streamed to the client, then the simulation for that replication focus instance is paused. So let's now take a look at stream out behavior. So at this current time, default is equal to low memory. And what this means is once an instance has been streamed to a client, only once that client's memory has become low will that instance be streamed out. So if I play the game, and if I set my character's walk speed to a very high speed, and if I start streaming in instances, these instances will only unstream once I run out of memory. And because there's currently not enough instances to make my computer run out of memory, these instances will never be streamed out, even if I walk a very far distance away from them. If we change the stream out behavior from low memory to opportunistic, what this means is when an instance is streamed to a client, once that client walks a certain distance away from that instance will be streamed out, even if the client has enough memory to store that instance. So the way we can calculate the stream out distance is to use the target radius. So to do this, we can do 128, so the target radius, plus half of the target radius, and half of 128 is 64, plus a static value of 64. So that means that if we use opportunistic with the target radius of 128, the instances will be streamed out at a radius of 256 studs. But if we have a target radius of 512, then the way we would calculate it is the target radius, 512, plus half of the target radius, which is 256, plus a static value of 64. So if we have a target radius of 512, then instances will be streamed out a distance of 832 studs. So let me change this back down to 128, and let's go to the test tab and start a local server with one player again. And now what we should notice is if I move towards an instance, it streams in, and if I walk away from an instance, it streams out. Now one thing we need to be careful is, because the instances are constantly streaming in and out now, it may use more network data than before. So here we can see we have the default of 0.15, and if I keep moving back and forward, because the server has to constantly stream the same instances to my client over and over again, we can see it's using network data. Another thing we should take note is, even if my client deletes an instance, for instance, let's delete this instance over here. Let's now make the server move this instance that we deleted. We can see that even though the client deleted this instance, the server is unaware that the client deleted this instance and is still sending the position of this instance to the client. So we can see it's at 0.15. If I start to move, we can see it goes up. So what this means is, if you're trying to make your own custom version of content streaming, you're most likely not achieving the same thing as Roblox's content streaming, because even if I move this entire folder into replicated storage, so now we're no longer rendering any of the instances, if I move any of the instances that have been streamed to the client, it's going to consume network data. So I can start moving this. We can see it's sending packages. And if I move an instance that has not been streamed to the client, so this is using Roblox's content streaming, you can see it uses no data. So simply moving the folder in and out of the workspace is not replicating Roblox's content streaming. So if you're not too sure whether or not to use low memory or opportunistic, I would say low memory is good for large worlds that are static and don't move. That way, you only have to stream the content once to the client, and as long as they've got enough memory to store all the instances, you'll never have to stream the instances again. But if you have large worlds with many moving instances that are moving on the server side, then it may be better to use opportunistic. So let's now take a look at model streaming mode. So if I create a model, and we can see that we have a property here called model streaming mode. Now, if you have streaming enabled set to false, this property will disappear. So make sure we have streaming enabled set to true. And now we should see model streaming mode. Now, the value of default at this current time is equal to non-atomic. And to test the model streaming mode, what I'm going to do is select the children of my folder, and I'm going to move all these children into my model. And I'm going to delete this folder. And then I'm going to move all these instances up to here. And now I'm going to go to test and create a local server with one player. So what we should see now is, just like before, we have the model, and inside of the model we have all the instances on the server side. But for the client side, we have the model, and we can only see the instances that have been streamed. And as the client walks away, the instances are removed because we're using opportunistic. And as I walk towards the model, the instances come in as I get close to the instances. So it's exactly the same as the folder. But if I select the model on the server side and change the streaming mode from non-atomic to atomic, we should notice that the entire model gets streamed to the client. And if the client starts to walk away, instead of the instances streaming out one at a time, we can see that the entire model gets removed from the workspace. And if I walk back, we can see the entire model gets streamed in again. And if we go back to non-atomic, we can see that now all the instances go away, and only the instances within the model that are close to my client are streamed in. And if I walk super far away from the model, we can see that the model stays in workspace, but it just has no children. Now, one benefit of non-atomic is the server could set an attribute for this model. So let's create an attribute called test. And now, even though the model's instances have not been streamed to my client, I still have access to this model's attributes. And if I change this value from 0 to 5, it replicates to the client. But if I change the model's stream mode to atomic, now the model gets unstreamed from the client, and the client can no longer see the test attribute, and this attribute will no longer consume network data for this client because the server will no longer send this attribute to this client whenever it's changed. And if I walk back in, and now I can have access to this test attribute. And let's, for instance, assume that our server has 2 players, and by default, the players' models will be set to stream mode default, which is the same as non-atomic. And if player 1 walks away from player 2, and we look at player 2's contents, we can see that it contains meshes, and it contains a humanoid and some other things. So as we walk away, we can see that the meshes get de-streamed, but we still have access to all these other instances. For instance, I can look at the humanoid, and I can look at the player 2's health, and if the server changes the health of player 2, so let's change the health of player 2 to 50, we can see it replicates to player 1. And if the server changes player 2 from default to atomic, now we can see that player 1 can no longer see player 2's model and has no longer access to player 2's humanoid. So if I walk close to player 2, the entire model reappears. If I walk away, the entire model disappears. So the benefit of using atomic, it's going to help use less network data because now the entire model is going to be removed from any other player that's not standing close to player 2, and so the server will no longer need to send the health or any kind of attributes or any kind of property changes for these instances within player 2. But the benefit of using a non-atomic is that these instances do stay for other players, and now the other players can have access to the humanoid health or any of these other properties for these instances. Another streaming mode we can select from is persistent. And if we have persistent selected, that means that this model will be streamed to all other clients at all times. And finally, we have the persistent per player mode. Now, if I select persistent per player, but let's do this on the model. So I'm going to set this back to default, and I'm going to select the model with all these parts, and I'm going to set this to persistent per player. Now that this is set to persistent per player, it's going to work just like atomic. So if I go to player 1 and player 2, if I move away from the model, the entire model gets removed. And the same is for player 2. If player 2 walks away from the model, it gets removed. But what I can do is I can go back to the server and I can say workspace.model, and then I can say add persistent player, and let's add it to player 1. So I'm going to say game.players.player1, and I'm going to set this as persistent. So now for player 1, the model is persistent, so that means it's always going to be streamed to player 1, even if I walk a very far distance away from it. But for player 2, it's going to be working like atomic. What I've done now is created a brand new model with 3 parts within the model, and we're now going to look at the level of detail property. So at this current time, the value of automatic is equal to disabled. So what this means is when a model gets streamed out, nothing is going to take its place. But if we set it to streaming mesh, then what that means is when this model gets streamed out, an imposter mesh is going to take its place in order to emulate this model. So I've now started a local server, and we can see the server on the left side and the client on the right side. And we can see the model. We can see streaming mesh is enabled for level of detail. And we can see all the three parts on the client side. And as soon as the client walks away from this model, then the parts should start to unstream. And once this model streams out, an imposter mesh is going to be placed in its position to emulate this model. So let's start walking away. And now we can see that all the parts inside of the model have disappeared, but I can see this model that emulates the three parts. And if I walk back, we can see the three parts come back and the imposter mesh disappears. Now, if I walk away so that the imposter mesh takes its place, and we can see this imposter mesh. Now, if the server decides to move one of the parts inside of the model, for instance, if we move the red part to the right, we can see that this change does not reflect on the client. But if the server moves the entire model, we can see that this does replicate to the imposter mesh. And then once the client walks back towards the model so that the three parts stream back to the client, then the red part is going to jump to the right to match this position. So let's start walking back. And we can see the part snaps to the right. Now if we walk away again, it goes back to the previous imposter mesh. Now if I duplicate this model, and if I move this model to the right, we can see that this duplicated model has the exact same imposter mesh as the previous model. And if I walk back, we can see that they snap to the right. And if I move this part inside of this duplicate and I move away, we can see it still has the same imposter mesh. And if I create a brand new model, and if I create a part for this model, and if I anchor this part, and if I create a few duplicates of this part, so we now can see these three parts on the client side. And if I set this model to streaming mesh, and if I walk away from this model, we can see that the three parts disappear and there is no imposter mesh for this brand new model. So the reason for this is if we read the documentation, we can see that the imposter meshes are pre-computed during the studio session and serialized and uploaded as part of the place file. So what that means is the imposter meshes are generated outside of game and not while the game is running. Another thing we should take note is even though that this model is now streamed out and has been replaced by an imposter mesh, because we're using an imposter mesh, if I enable network stats, and we can see the overall incoming kilobytes a second is 0.15. If the server starts to move the model, we can see that even though the model is streamed out, it still consumes network data because it has to update the position of the imposter mesh. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.